I have received many questions about the class test. Many of you asked it for a mock test, which is now on Learning Central, the one that you see on the screen now. I thought it might be a good idea today to go through the mock test together and see or try to answer any questions you may have about the mock test. You still can email me your questions if you have any questions after the lecture. But if you have questions during the lecture, it would be great. Just raise your hand and ask your questions straight away. Just as a reminder, the class test will take place in week 6 during Friday's lecture. The same time, the same venue. Try to be on time. Try to arrive early on Friday. I will remind you again on Monday, but if you have to make any arrangement to or to change your arrangement to arrive at least 10 minutes earlier than usual, that would be great, because this is an exam, so you need to be on time. So please make sure you arrive at least 10 minutes before the lecture. This is how the class test will look like. So this is not the class test. This is not what you're going to do. Those who attended the tutorial this week, or they know how to work out the equilibrium output. So if you have some information about the economy, some information about consumption function, investment, government spending, how can you use this information to find out the equilibrium output? And that's why it's important to attend the tutorials, because the tutorials complement what we do in the lecture. So in your test, you're not going to have just information about the goods market to find equilibrium in the goods market. You'll have information about both the goods market and the money market, and you should find the simultaneous equilibrium, where you basically want to find out Y and R, the output level and the interest rate level. We have some information about an economy. It's a closed economy, so that means no exports, no imports. So in this question, suppose we have a closed economy. As I said, closed economy means exports and imports equal 0. So we have a few equations here about consumption, about investment, about government spending, taxes, money demand, and money supply. And what we need to do here, first explain the meaning of equation 1. Consumption function. Investment depends actually on the interest rate. And in the last lecture or the lecture before, we said also we make that distinction between the nominal interest rate and the real interest rate. So what you see here is the investment function. As we discussed in the tutorial this week, the investment here depends on, or has two components. One component here, which is the I0, which is not related to the interest rate, so it doesn't depend on the interest rate. And this is the other component here, which depends on the interest rate. We know there's a negative relationship between the interest rate and investment, so we would expect this H here, proportion of, or depends on, or a proportion of investment that depends on the interest rate. So R here is the interest rate. So the subscript means just time T. So you shouldn't be confused because you have a subscript T here, just time T, or current period. So we have two components, as I said. So the first component is the level of investment, that basically that is a kind of compensation for investment depreciation. So if you want to keep investment at the same level, you want to keep this, probably this should be positive then. So we expect this I0 to be positive. H here, we expect this coefficient here to be negative, because we know that the relationship between interest rate and investment is negative. And as you will see later in the question, it's already point or minus 20 here, so it's kind of a negative number. I'm talking about H here, this H. G is the government spending, and I'm using small letters here just to denote that these are in real terms, sorry. So in real terms means that you took into account the inflation or the prices. So T again, this is the taxes one, and these two variables here, G and T are exogenous, so that's why you see that bar. So they are given. This is a function for money demand, and this is money supply. So basically money supply is given, so that's again, it has like a bar on it, so it means it's exogenous variable, so it's given. On this side, in this equation, you'll have two components. Remember, what determines demand for money? Why do we demand money? Why people want money? The first one is for transaction, and that depends on income. That's exactly the first part of this equation. Okay? So this first part here is K times YT. YT is income in time T. Okay? So this is the part of money demand that depends on income level. On the other side, or the second part, which is negatively related to the interest rate, that's exactly what we discussed in the lecture. So we said money demand depends on two things: the income level, and it's positively related to income, and the interest rate, and it's negatively related to the interest rate. So anyway, so now we have some information about, in B, we have information about some of these variables, and now we want to work out the equilibrium. So you have information about the goods market and information about the money market. So what you need to do is you need to get the equation for the IS and the equation for the LM, make these both equal, then you find the equilibrium point. We show some example last lecture, and again, do that example again, please. So you need to practice that example. C0, it's 180. We have C1, which is 0.8. Oops. And I0, which is, that's I0, sorry, which is 160, and H, which is minus 20, G 163, and T is 120. K equals 2, theta equal 10,000, and then the money supply equals 3,560. So this is the kind of information we were given in part B, and we want to find the equilibrium output and the equilibrium interest rate. Okay, so as I said, so now you have information about both markets, the goods markets and the money markets. So you need to find an equation for the IS and the LM equation. So we already know the equilibrium in the goods market, which happen when Y, or the output level, equal aggregate demand. So we could just use this information. So we know that this Y should equal C0 plus C1 times disposable income here, which is Y minus T, plus investment, and this is the investment function, plus HR, plus, I'm just going to ignore the subscript now, just to make it easier. So that means we're just going to use this information. So C0 is 180 plus C1 is 0.8, YT, this is what I want to find out, but I have T here, T is 120 plus I0 is 160 and minus 20, because H here is negative value here, so it's negative 20 times R, which I want to find out, so it's unknown, plus G, which 163. So from this, if you simplify this, then you could get an equation, or IS equation, okay? Then from the money market equilibrium, you could get LM equation. Make these two equal, then you get, is it clear? Can you read the what I'm writing. From here, so it's very straightforward. So what you need to do, just expand this 180 plus, so that's 0.8 yt. So I'm expanding this. I'm just going to ignore the subscript, and this 0.8 times 120, that's minus 96 plus 160 minus 20r plus 163. So when you simplify this, you will get something like 407. So you add this minus this plus this plus this. This is 407 plus 0.8 y minus 20r. So I want these y's the other side here. So that means this is y minus 0.8 y. Equals this 407 minus 20r, so that's mean 0.2y equals this 20r, and then I just want an equation of y. Okay, so y here, so you need to divide by 0.2, so that should give us 2035 minus 100 r. So this is IS equation, or equilibrium in the goods market. Okay, so what I need to do next is to find the equilibrium in the money market. So in the money market, we know that equilibrium happen when the demand for money equal money supply. So we know all the information about this. We know the demand, the money demand function, which is ky minus theta r equal money supply here is given, is constant. So if you remember, this is money supply here. So we're giving that already. So, but I'm just going to write this equal money supply, and then so k is given. K is 2 from here, and also theta is given. So we know both k and theta. So I'm going to replace this. This is 10,000 r equal 3,560. Yes. So again, you can just simplify this. We just want an equation of y. So so that means 2y equal 3,560 minus 10,000 r. Okay. So from here, just divide by 2, and that means y equal 1780 plus 5,000 r. So this is an equation for, or this is like LM, or this is from the money market. Okay, so what I need to do here is, you remember the equilibrium happen when IS meets LM in one point, and that gives you y and r. So all what I need to do here is just to say, okay, if y equal this and y equal this, an equilibrium happen when these two meet each other. So that means this is 2,000. You can make these both equal, minus 100 r equal 1780 plus 5,000 r. And from here, so now we have one equation and one unknown, which is r. So what I need to do now is just to solve this for r. Solving this for r should give me r equal 0.05. So 5%. So the equilibrium interest rate is 5%. Okay. All what I need to do now is to use this 5% in any of these equations to find y. Okay. So from here we could say, okay, if y equal, I'm just going to use the first equation, 2035 minus 100 times 0.05. Okay, and from here then y equal so that answers the first question. Okay, so the equilibrium interest rate is 5% and the equilibrium output is 2030. So the next point, is this clear? So I hope it is very clear. It's straightforward now. So what you need to do, you have information about the IS or about the goods market. You have information about the money market. So if you get the equilibrium here, work out the equilibrium in money market, the equilibrium in goods market, and then you have two equations, two unknown, then you can solve for these two unknowns. So you can find out how much they are, Y and R. So the second part of the question, based on the information here you're given in part B, how much will equilibrium output change by in percentage term if there is a 5% rise in government spending, ceteris paribus. So you could do that by let's go back. So now we have 5% change in government spending. So if we know how much is that, so government spending was 163. Okay, so now this has changed by 5%. So equal 5%. So how much is that 5% from this? So what I'm going to do is just to calculate how much the change in Y was. So in that case, so let's call it G2. So that, yeah. So in that case, G2 equal will be 163, that's 163 times 1 plus 0.05. So 0.05 here is the 5% change. This will give me the new level of government spending, which is going to be 171.15. So now the government spending changed from G1, which is 163, to G2, which is, and that's a 5% change, which is 171.15. So the question now, how is this going to change Y, and what R is going to be? So what you need to do now is to just follow the same. So obviously the LM equilibrium, this will change the IS or the goods market equilibrium. So what we had before, we had Y equal, I'm just copying everything from before, 0.8 Y minus 96 plus 160 minus 20R. So I haven't changed anything so far. This is exactly the same equation we had before. The only thing has changed here is G. G here is not 163, it is actually 171.15. So from here, you can work out the same way. You find an equation of Y, and from here, that means Y will be 275.75 minus 100R. So if I have this now, and I know that in the money market, this is the same condition from before, which is 1780. Plus 5,000 R. So this is the new one. So this is the new equation. This is the previous equation. This is the same equation from before, because now government spending has changed. So from here, we could actually say, okay, so that means 2075.75 plus or minus 100R, which is the first equation, equal 1780 plus 5,000 R, and from here you can find out that R actually is 6%. So R has changed from 5% to 6%. Once you get this, you can just plug this into any of these two equations. The first one or the second one is not going to make any difference. So that means Y, I'm using the first one, 0.75 minus 100 times 0.06. And from here, y will be 20, kind of 69.95, something. Sorry. Okay. So is it clear now? So the only thing I need to do now is just to work out the new equation for the goods market, and then use that to find the new equilibrium point. So in the second part, or sorry, in part D, what we want to do here, we want to use a diagram to explain this effect when G changed, how this is going to change equilibrium on a diagram. So the way you do that is, we know now you're very experts now in this, so you know how to do that. So the equilibrium in the goods market have measure Y and the aggregate demand, and then now we know the 45 degrees line, and then what we have, let's say, an initial equilibrium point. So this is the aggregate demand, let's call it AD1, and this is the, let's call it Y1. So this was the first equilibrium point, and now because of the change in government spending, what's going to happen to the aggregate demand curve? Please, someone tell me. Yes, thank you. It will go up. Okay, so at least I know now somebody's following. Okay, so it goes up because what happened here, delta G is greater than 0, or we know that actually delta G equal 5%, change by 5%. So we know that from the question. So now what happened to the output level? So this is output level, so that has increased. Okay, so the question, the last part in the question, I'd ask you if a multiplier effect has occurred. So did we see a change in the output level that is more than 1-for-1 change when government spending increased? That's what we need to show. Okay, so we need to show it. Delta Y over delta G. So delta Y has changed from, Y has changed to 2069.95 minus 2030. So that was the first one. So that was Y1, and that was Y2. Okay, and G changed to 171.15 minus, and that was from 163. Okay, so this is the old one, this is the new one. The same thing applies for G. So it's just a change in Y over change in G, and that gave us 4.9, which obviously is greater than 1, so that means there's a multiplier effect here, because when you change government spending, the output level change by more than what you change in government spending. So it's more than 1-for-1 change. Okay, how do you know that? Because the change in this over the change in this give us 4.9, which is greater than 1. You should know now, if you have information about both the goods market and the money market, you should use both, or all information you have in both markets, to get the equilibrium point, to find the equilibrium point. Money demand function like this. So, and then we're given some these parameters here, or K, alpha, beta, we were just given how much they are, and then we were asked about the income elasticity and interest elasticity of money demand, or demand for money. If you remember in the lecture, we highlighted that the slope of the LM curve depends on how sensitive money demand for income and how sensitive money demand for the interest rate. So the idea of how sensitive is actually, this is the elasticity. Okay, so that's what we mean by elasticity. Okay, so And here we're given the form of the demand function, demand for money function, and then we were asked to find out the income elasticity and interest elasticity. Okay, so what we know from here, we know that this is the demand function. So equal k y to alpha r to beta. This is just given in the question, okay? So, and we also given that, we know that k equal 0.6, alpha equal 0.7, and beta equal minus 0.3. So the question is, we want the income elasticity of money demand and the interest rate elasticity of money demand. So what is elasticity? So the elasticity, you remember the way I put it in the lecture is like how sensitive the change, or how sensitive money demand to the change in income. So elasticity is basically you're looking at the percent change elasticity in general. So you're looking at the percent change in Y over the percent change in X. So it's kind of percent change over percent change. So which approximately can be something like this, like mathematically. So it's kind of the, when you differentiate log or of Y over the of X. So what I'm going to do now is I'm going to show you that you could actually do the same here, and from here you can get something like this, which is you can basically get the len for money demand over this with respect to, so you differentiate this with respect to if you want, like you could do with respect, for example, to income, and that will give you, so this part here will give you the elasticity for the income elasticity of demand for money. So let me tell you how would you do that. So if you take the log in both sides, that will solve the issue. So that's what we need to do. So basically what we need to do here is say, so this is the len m d over p equal len the whole thing here, which is k y alpha r beta, log of this minus the log of this. So this is len m d minus len p, and this is going to be len k, which is kind of constant, plus, so to take the log of this one, so you take this, the power down here, so that's alpha times the log of y plus beta, so the same beta times the log of, or the len r. So what I need to do here, I just need the money demand on one side. Okay, so that means ln md equal everything here. So this is L and K plus alpha, then Y plus beta, then R plus then P. Okay, the price. So now from here, so you can really get the elasticity, so which is again taking you back to this point here. That's what elasticity means in this. So you just need to differentiate this with respect to Y to get the income elasticity, or with respect to R to get the interest elasticity. So in that case, so that means, let me just put it in, how does that mean? So that's percent change in M in money demand over the percent change in Y. That is equal, which means you differentiate basically this ln md with respect to ln y. That's going to be alpha. Okay, so what we could also, the same way you could, so this is the elasticity of which is actually given to us. You remember, we know already alpha here is 0.7. Okay, so the same thing here with or the interest rate elasticity of money or demand for money is going to be beta, which is already given. So what does that alpha mean? Income elasticity of money demand. Can anyone explain it? You've done elasticity in macroeconomics, so it's the same concept. Percent change over percent change. What does that mean in this context? So when income increased by 1%, is that right? Yeah? And then how much money demand will increase? It's 0.7. Okay, so that's the value, that's the elasticity. Okay, so it's percent change, or again it's percent change. Okay, so the same thing with interest rate is this one, is this line. So if you understand what that means, then you can do some, you take the log of both sides, and then you differentiate with respect to y, you get the income elasticity of money demand. The second question, let me just show you the questions. So by the way, all these questions you need to practice by yourself. Don't think because you've seen some instructions or what I've been doing in the screen that you should be fine. Like, you need to do it by yourself. And as I said before, these sort of things or math, you actually have to do it yourself. Otherwise, you'll find it, you might get lost. Okay, so how much will nominal demand for money change if there is 2% rise in real income combined by 5% fall in real interest rate? Now, I'm not going to give an answer for that. I want you to answer that. Any ideas? So what we know now, or what the question is asking, is how much money demand will change if there is 2% rise in income and 5% fall in interest rate. Okay, I'll leave that with you then. The other type of questions that you might get something similar, which is again the idea of having a value for the money supply, having the value for price, okay, and the real national income, which is Y, and then calculate the equilibrium interest rate. So I think this is very straightforward now. You know how to do that one. Money supply, and we want to calculate the equilibrium interest rate. We already given the money demand. Is that right? An equilibrium happens when money demand equal money supply. So going back to the first question, you do the same thing. Okay? But now you'd be just looking at the money market, not both markets at the same time. Okay? You have money supply and you have money demand. Then both equal. You're already given Y, the output or the income level. Then the only unknown here is R. So it's only one equation, you solve it for R. So that should be very straightforward. Okay? Okay, so suppose that central bank plans to lower equilibrium real interest rate by 1% by adjusting the supply of money. What would be the new required level of money supply? So in this case, you have how much the change in R, or how much R will be, but now what is unknown here is the money supply. So you still can use the same, but the unknown here is going to be, you're giving R, and then the unknown will be money supply. So you have money supply to work out how much is that. Okay, just keep the equilibrium in mind, yeah? So every time you need to think about the equilibrium in this market. Okay, how does the equilibrium happen in this market? Money supply equal money demand. Okay, when you put these together, you have all the information you're given. You have only one thing is not known to you, which is money supply. So just work out how much money supply should be to give us this sort of equilibrium at this, or the equilibrium at this level of the interest rate. Is this clear, guys? Okay, I hope so. Anyway, The last question, which related to the plotting or drawing this on a diagram. So, I'm just going to show you, which we already did this before. If you remember, we did how equilibrium in the. So there are a few questions or a few examples of these, but let me just show you how does that work. So basically, what we know now is we're talking about the money market. So we know from what we studied before that money supply and money demand, we plot these on the R, or the interest rate, and the money stock space. So we know that we treated money supply as given. So this is money supply. And what happened here is, okay, equilibrium, or the initial equilibrium point happened when the money demand meet the money supply, and this is, let's say this is R1 or R0, let's call it R0 because we move from 0 to 1. So this is the initial equilibrium point. So what happened here is, in this question, there was an expansionary policy which shift this money supply curve to the right. So the question here, what would happen to the interest rate? So moving from this to this, now we say this is, let's call this M0, MS0, this is MS1, and now what happened is, now the interest rate has fallen from this to this. Remember, we moved from M0 to M1, so that means this is an expansionary monetary policy. So now we have a new interest rate. Okay, what I'm going to leave with you as well, so I left with you a few things to think about and to see how to do these things, is how this will affect the bond market. Remember when we studied the equilibrium in the money market, we said if financial wealth could be split between two assets, money and bonds. Okay, and we assume there's only a single interest rate at that point, and the equilibrium in one market implies the equilibrium in the other. So equilibrium in the money market should give the equilibrium in, or the interest rate, or the equilibrium interest rate in the bond market. So the question asks you how the bond market will react to this change. So again, this is something for you to think about. What you need to do, as you see, you need to practice how to find equilibrium in different situations. Okay, you need to answer the tutorial sheet. The tutorial sheet really is going to help you. Also, the example we did last lecture, so that you can find this in the lecture notes and it's recorded, and also this example as well. And the questions are on Learning Central. If you have any questions, please email me. Thank you so much.